Hi guys, welcome back to my channel. So in this video I'm gonna go over a Cal 2 topic, which is to find the volume of a solid using the washer method. Alright, so we have a problem over here which says find the volume of a solid obtained by rotating the region enclosed by the curve y equals to 2 minus square root of x and the lines y equals to 2 and x equals to 4 about the x-axis. Alright, so to solve this problem, first of all, we're gonna have to draw the graph over here. Okay, so this is the axis. So x-axis, y-axis, and first we have an equation over here, 2 minus square root of x. It's a square root equation, as you guys can see. There's a square root over here, and if you don't know how to draw the square root equation, then let me just do a quick refresher. So this is y equals to square root of x. Since this is a positive, so we will draw it like this. But here we do not have a positive. Here it's a negative. You can write this in a better way. You can write it like 2 minus, you can move the 2 over here so you can better see that it's a negative square root of x and then positive 2. Okay, so here, as you guys can see, that's a negative in front of the square root. So I'm gonna remove this. So you're not gonna draw it like this. So then in the negative case, your function is gonna look something like this. It's gonna touch the axis. Okay, and to be able to know when it touched the axis and where does it actually starts, we're gonna have to find the axis, the x-axis and the y-axis. And here, just right from the equation, you can see that there is a positive 2 over here, which means this is the y-intercept. So we already know now the y-intercept, which is 2 over here. Now we need to find the x-intercept. So to find the x-intercept, we know that we are looking for a value of x for which the y value is equals to 0. So we're going to plug in y equals to 0 inside the equation. So putting y equals to 0, we're finding for x. So moving the 2 over there, just doing some algebra. Negative cancels out, 2 over 2 equals square root of x. Now the square root cancel out with the square. So 4 equals to x. So we have just found the x-axis, which is x equals to 4. So 1, 2, 3, 4. So it cuts over here. So now you know how to draw the square root function. So it's gonna look something like this, right? Okay. So next we have y equals to 2. So y equals to 2, it's y, right? So y equals to 2 would simply be a horizontal line over 2. And next we have x equals to 4, which is simply going to be a vertical line over 4. So this is your, so this is your curve. Okay, and this is your region then. Alright, so let me write which one is which equation so you guys don't confuse. So this is x equals to 4, this is y equals to 2, and this one is, and this one is y equals to 2 minus square root of x. Okay. So next our problem is to find the volume of a solid. For this we're going to use the washer method, which is simply to subtract the outer radius minus the inner radius and then integrate it. So we have an outer radius over here. So so this is what it's gonna look like when you're going to do the rotation about the x-axis, right? So you guys are rotating it about the x-axis. So you guys see that when you rotate this region about the x-axis, it's gonna eventually form this shape, right? So that's why we call it a washer method. and we are going to, in this washer method, we're going to slice the solid that it's gonna form, like when we're going to rotate it, it's gonna form a solid, right? And we're going to take a piece of that solid and then find the volume of that solid. Okay, and for this we're going to have to take an outer radius and subtract it with the inner radius. Okay, so this is the inner radius. Oops, this is the inner radius. And oops, this is the outer radius. This is the whole object, right? So the outer radius would be this. So this is the outer radius. You want me to put it in green? Okay, fine. And yeah, by the way, you guys don't have to write the notes. I'm gonna provide the notes in the description below. Alright, so we have the outer radius over here and the inner over here. Next job is to find the volume. So volume is given by a to b, the integral between a to b, and then the outer radius r of x minus the inner radius. And then since you guys see it forms like a disk, and and the area of the disk is pi r square. So we're going to take the volume. To find the volume, we're going to integrate this. So the area is pi and then r square. So this is the r, right? So you're going to r square it. R square. Okay, so squaring this and squaring this. And here you guys see that we are rotating about the x-axis. So we're going to put a dx over here. We're differentiating with respect to dx. Why? Because rotating about the x-axis. If we were rotating about the y-axis, then we would put a dy over here. Okay, let's continue with the problem. So here, let's set up the limits of integration. So here pi goes over here because it's a constant, it stays outside the integral. Here we have, we're differentiating with respect to dx, right? So we need to put the limits in terms of x as well. So look at where the region is in terms of x. So the region belongs to x from 0 to 4. After 4, there's no region, right? So the region is within 0 to 4. So these are my limits of integration. So it starts from 0 and goes up to 4. Alright, so what's my bigger radius? So the bigger radius is simply the distance from the origin to y equals to 2. So here, right? So starting from here to here, so that is simply 2. Okay, so it's squared, right? So we're going to square it. This is the radius and then squaring it. And what's the small radius then? Okay, so small radius, we always write it in terms of the equation that we are given. So here we have the given equation 2 minus square root of x, right? Because look, the radius, it is touching this line, right? So we're going to write this, that the smaller radius 2 minus square root of x, this distance. Okay, so then 2 minus square root of x is our smaller radius, and then square, of course, because it says to square the smaller radius. And now we have set up the integral. Now the rest is so easy, right? Okay, so here this is 4 minus 2 minus square root of x squared dx 0 to 4 and pi. And here, be careful. Do not write this like 4 minus and then square and x cancels out, so it's only x, 4 minus x, and then this 4, right? You cannot do this. This is wrong. Why? Let me show you why this is wrong. Okay, so you guys remember the equation that you guys learned in high school, a minus b squared. This is what you're going to use, right? A squared negative 2ab plus b squared. Okay, so this is our a and this is b. Okay, so this is 4 minus and then a, so a squared, so that would be, we're going to multiply this negative after, so I'm going to put a big parenthesis over here. Okay, so a squared, that's 4 minus 2ab, so multiplying ab, that gives us negative 2 square root of x, and then multiplying with this 2, that would be 4 negative square root of x, and then b squared. So this is b, we're squaring it, so the x cancels out with the square, and the square and square root cancels out, so we're left with positive x. Okay, so this is this, and then yeah, not forgetting the parenthesis then. Okay, so now what's next? Okay, so next we have to multiply with this negative. Don't forget this step. This is very important, otherwise it's gonna ruin your answer. So this is gonna turn into negative 4, negative of positive 4 square root of x, and then negative x. Okay, so now we do not have any parentheses. Okay, so 4 and 4, that's simply 0. And we are left with 4 square root of x, negative x, 0 to 4 pi dx. I guess now we can integrate. There's no simplification needed. And how do we integrate this? So you guys see this is square root. This can also be written as x to the power of half. X to the power of half is the same thing as x squared. Okay. So this makes our life easier to integrate, because now we can add plus 1 and then divide it by plus 1, right? Adding the exponent, so half plus 1, that's 3 over 2, and dividing by 3 over 2 then, and negative x squared divided by 2, 0 to 4, and yeah, not forgetting the pi. And this is after the integral. Now let's solve it. I can just distribute the pi, let's see. Okay, so then this is gonna be x squared divided by 2 pi 0 to 4. Okay, so we're going to plug in 0 first and then subtract it from the 4. So putting 0, it's simply gonna make into 0, right? 0 pi minus 0 pi. So this whole thing is simply gonna be 0. And then negative, putting 4 inside it. So 4 to the power of 3 over 2 divided by 3 over 2 pi minus 4 squared divided by 2 pi. And if you do all this math, this should give you 40 pi over 3, and that's the final answer. Thanks for watching, and yeah, don't forget to download the notes from the description below. Bye.